Universitas Muhammadiyah Magelang has become a milestone in facing an increasingly competitive and inclusive era, forming superior generations in science and Islamic in behavior.
Welcome to UNIMA. With philosophical values, spirit, and new way of thinking, UNIMA step in by continuing to develop science and technology, build network, foster a sense of love, and improve the service quality of the four pillars of higher education.
In preserving environment and commitment with society, UNIMA always participate to create synergy and collaboration with community. With a prophetic spirit, ethos, and motivation, UNIMA is ready to shape qualified religious students capable in forming superior in science, Islamic in behavior graduates. To optimize the education and learning process, UNIMA is supported by various representative supporting facilities. UNIMA has 7 faculties with 21 study programs. Faculty of Economics and Business, Faculty of Law, Faculty of Teacher Training and Education, Faculty of Islamic Religion, Faculty of Engineering, Faculty of Health, Faculty of Psychology and Humanities. UNIMA implements its support for non-academic activities by fully supporting student character building activities through various student organizations. To become an inspiring generation, everyone is equally in achieving their dreams at UNIMA. UNIMA, moving and inspiring.
Ladies and gentlemen, as we are about to begin, please be seated. I have a note to make before we begin today's event. I would like to seek your cooperation in completing this event. Kindly switch your audio into silent mode to avoid interruption. Thank you for your kind cooperative and attention. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Her Excellency Director of Universitas Muhammadiyah Magelang, respectable Vice Rector, the Director of Kohos University, honorable faculty member, speakers, and keynote speakers, and respectable all participants of this event. Welcome to today's event, the third Borobudur International Symposium in 2021. I am Pristi Sukma Setia, will be your master ceremony in today's event, and still relate to the big theme of reinforcement, the SDGs at the previous conference. We try to invite academics and researchers in the world to participate in the third Borobudur International Symposium in 2021. And for the third BIS 2021 main theme is a decade of action toward environmental issue, advancing the innovation to recover our planet. We would like to thank everyone here for making time to attend this remarkable event, for joining who are in Zoom and also YouTube. Ladies and gentlemen, on this occasion, allow me to introduce you to today's agenda. We will have opening ceremony in the morning and continuing with seminar session with special speakers all around the world from Indonesia, Malaysia, United Kingdom, Nigeria, Austria, and Vietnam, and so on. And in the afternoon, we will have an online question and answer session for all the participants in this event. The honorable guests, ladies and gentlemen, let's open this seminar ceremony by reciting Holy Quran that will be recited by Dwi Rahmi. Dwi Rahmi, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. والذين استجابوا لربهم وأقاموا الصلاة وأمرهم شورى بينهم ومما رزقناهم ينفقون. والذين إذا أصابهم البغي هم ينتصرون. وجزاء سيئة مثلها فمن عفا وأصلح فأجره على الله إنه لا يحب الظالمين. صدق الله العظيم. Wassalamualaikum warahmatullahi wabarakatuh.
Thanks to our sister Dwi Rahmi who has recited the Holy Quran for us. May Allah always give us guidance and help. Amin. And now let's start to move on to another agenda is singing Indonesian anthem, Indonesia Raya and Sang Surya. Ladies and gentlemen, now we would like to hear the report from the chairman of the third Borobudur International Symposium 2021, Professor Muji Setio. The time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, the honorable rectors, vice rectors, deans, faculty members, keynote speaker, and also the participant. Welcome to the third Borobudur International Symposium in 2021. Ladies and gentlemen, today we stand on the edge of industrial revolution that will drastically change in the way live, work, and community. This change is unpredictable in the term of scale, scope, and also complexity. As a result, we don't know the expectation and risks that might occur in the future. However, wise solution for this change must be integrated and comprehensive, involving all stakeholders from global to local governments, public and commercial sector, academia, and also civil society. On the other hand, environmental sustainability and welfare must be the main consideration and main focus in decision making in this period. For example, intelligent sensor combined with AI have demonstrated their ability in production processes, educational technology, and other activity supporting technologies. In this current period, smart and science-based solutions are urgently needed to the economic recovery. For scientific community like me, you, and scholar, research should continue under any condition. Therefore, this event is presented to share research experiences and report on the research progress of each institution, our and your institution include. Ladies and gentlemen, the main theme of the symposium is a decade of action toward climate change issue, advancing the innovation and recover our planet as a part of master plan of UN Nation for Sustainable Development Goal in 2030. So let me inform you that the symposium is attended by 442 presenters from 11 countries, include Indonesia, Morocco, Hungary, Malaysia, Thailand, Vietnam, UK, Austria, Netherlands, South Africa, and Nigeria. Certainly, this event will not be successful without the support of co-hosts. On behalf of our committee, I thank the co-hosts. Politeknik Kesehatan Karya Husada from Yogyakarta. Politeknik Negeri Samarinda from Borneo Island. Sekolah Tinggi Farmasi Muhammadiyah Cirebon. Sekolah Tinggi Ilmu Ekonomi Raja Wali Purworejo. Sekolah Tinggi Ilmu Ekonomi YPPI Rembang in Central Java. Sekolah Tinggi Ilmu Farmasi Yayasan Farmasi Semarang. Sekolah Tinggi Teknologi Muhammadiyah Cilengsi. Sekolah Tinggi Teknologi Warga Surakarta. Universitas Ahmad Dahlan from Yogyakarta. Universitas Al-Irsyad Cilacap. Universitas Harapan Bangsa. Universitas Islam 45 Bekasi. Universitas Islam Nahdlatul Ulama Jepara. Universitas Muhammadiyah Gombong, Universitas Muhammadiyah Palopo, Universitas Muhammadiyah Pekajangan Pekalongan, dan Universitas Muhammadiyah Ponorogo, Universitas Muhammadiyah Purworejo, Universitas Pelita Bangsa, Universitas Singapura Bangsa Karawang, Universitas Tidar, and Universitas Trisakti. Oh, just mention it make me tired, guys. Therefore, I present you world-class keynote speaker who am able to capture the scientific topic, and they are first, Professor Michael Hardy from Coventry University, UK. Good morning, Professor Hardy. Welcome to Indonesia. Dah. Yeah. Second, Associate Professor Tony Hadi Barata, PhD from Curtin University, Malaysia. Selamat datang di Indonesia, Dr. Tony Hadi Barata. Third, Dr. Rahmat Adi Wibowo, MS from Austrian Institute of Technology, Austria. Next, Professor Du An Thai from Thai Nguyen University of Economic and Business Administration, Vietnam. Good morning, Prof. Du An Thai.
Good morning.
Oh, nice to meet you.
Yes, nice to meet you, everyone.
Thank you. And the last, my close friend, Associate Professor Olusegun David Samuel from Federal University of Petroleum Resources, Nigeria. Please give them a big round of applause. Thank you. Finally, let me introduce our committee. First, Yulfikar Bagus Pambuko as co-chairman. Agus Setiawan, IT support. Krishna Bagus Edita Praja, event management. And our beautiful ladies, Feni Soraya Dewi, Lintang Mulyawanti, and also Fitriana Yulia Stuti as organizing member. Thank you. Lastly, have a nice discussion, and I love you all. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much, Professor Muji Setio, for the report. And the honorable participant, now we will hear the opening speech that will be delivered by Rektor Universitas Muhammadiyah Magelang, continuing to officially open the third Borobudur International Symposium 2021. Dr. Lili Andriani, MSI, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Innal hamdalillah nahmaduhu wa nasta'inuhu wa nastaghfiruh wa na'udzu billahi min sururi anfusina wa min sayyiati a'malina may yahdihillahu fala mudhillalah wa may yudlil fala hadiyalah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh la nabiyya ba'dah. Good morning, ladies and gentlemen. See you again at the third Borobudur International Symposium 2021. The honorable keynote speakers, Professor Michael Hardy from Coventry University, United Kingdom, Associate Professor Dr. Tony Hadi Barata from Curtin University, Malaysia, Dr. Rahmat Awibowo, MS, from Austrian Institute of Technology, Austria, Professor Du An Thai from Thai Nguyen University of Economic and Business Administration, Vietnam, Associate Professor Olusegun Samuel from Federal University of Petroleum Resources, Nigeria, Professor Dr. Muji Setio, STMT, as the chairman of the third Borobudur International Symposium 2021. Co-host college leaders and all the happy, blessed audience. Distinguished professors, lecturers, researchers, ladies and gentlemen, on behalf of Universitas Muhammadiyah Magelang, UNIMA, I would like to express my sincere gratitude and welcome you to virtual conference the third Borobudur International Symposium 2021 on Science and Technology, as well as on Humanities and Social Science, with the theme, Decade of Action Towards Climate Change Issues, Advancing the Innovation to Recover of Planet, organized by Universitas Muhammadiyah Magelang with 22 co-hosts. This activity was also held as a form of gratitude for the 109th anniversary of Muhammadiyah celebration on November 18, 2021, which carried the theme Optimistic in the Facing the COVID-19 Pandemic, Spreading Key Values. In Indonesia, optimis hadapi pandemi COVID-19, menebar nilai utama. The General Chairman of Central Executive of Muhammadiyah, Haidar Nasir, gave a message of us to continue maintaining the spirit of optimism and togetherness values, especially during the COVID-19 pandemic. Since the beginning, Muhammadiyah has been consistent in continuing to thrive with all its capabilities, sources of fund, resources, and system, and we have mobilized to be part of providing solution as well as optimism in facing the very difficult pandemic. Next, I would like to thank the keynote speakers. First, Professor Michael Hardy, who has expertise in intercultural relation and will present about beyond COVID, solidarity or fragmentation, where does leadership come in? Second speaker, Associate Professor Tony Hadibrata, who expert in environmental engineering and will present about involvement of the ligninolytic system of fungi and better transformation of emerging contaminant. Third speaker, Dr. Rahmat Awibowo MS, who has expertise in energy conversion and hydrogen and will present about material synthesis of Earth's abundant Cu2Zn SNS4 14 film photovoltaic. Fourth speaker, Professor Duan Tay, with expertise in economic and business and will present about circular economic. Is it an optimal economic model to mitigate the impact of climate change? Fifth speaker, Associate Professor Olusegun De Samuel, who expert in thermofluid option and will present about enhancer for biodiesel industry and development of empirical model to forecast its diesel engine performance indicator. Thank you for being the keynote speaker at the third Borobudur International Symposium 2021. Even though we have time differences, you are still pleased to share knowledge and experiences directly. Good morning in Indonesian time and welcome to Universitas Muhammadiyah Magelang. Thank you. Thank also to colleagues who have contributed to the third Borobudur International Symposium 2021, particularly to the 22 co-host institutions. Ladies and gentlemen, this conference was very interesting because it carried the theme Decade of Action Towards Climate Change Issues, Advancing the Innovation to Recover of Planet. Today, progress is being made in many places, but overall the action to meet the goals is not yet advancing at the speed of scale required. The decade of action call for accelerating sustainable solution to all the world's biggest challenges, ranging from poverty and gender inequality to climate change and closing the finance gap. This conference is expected to support the United Nations agenda, especially on clean water and sanitation, affordable and clean energy, industry, innovation and infrastructure, sustainable cities and communities, responsible consumption and production, climate action, life below water, and life on land. This is important. As we know, the COVID-19 pandemic and its impact on all the 17 Sustainable Development Goals, SDGs, have demonstrated how what began as a health catastrophe swiftly transformed into a human, socio-economic, and environmental crisis. While the crisis is imperiling progress toward the SDGs, it also makes their achievement all the more urgent and necessary. It is essential that reason again are protected and must be possible. A transformative recovery from COVID-19 should be pursued, one that addresses the crisis, reduces risk from future potential crises, and realizes in implementation effort to deliver the 2030 agenda. Furthermore, the COVID-19 pandemic has revealed the international interrelationship between the environmental and our livelihood. Climate change is our next big challenge, and it's around the corner. Achieving net zero emission required rapid economic, social, and technology transformation. Many countries are taking action, but progress is insufficient to achieve the goal of the Paris Agreement. Ladies and gentlemen, facing the challenge currently at UNIMA, we are focusing on innovation and digital transformation. The innovation in question is an effort of adapt to new habits due to COVID-19, which has impact on all sectors alive. Today, in the midst of an increasingly complex global situation and the challenges of a pandemic that has not ended, innovation and creativity deserve to be continuously studied and developed. Innovation and creativity are key points to survive the pandemic and global complexity. We are from the academic community, UNIMA. We try to do our best to develop ourselves and help the community and facing the new normal with various useful innovation. Finally, we really appreciate this agenda. This nation desperately needs fresh ideas for the massive changes. We hope that the discussion at the third Borobudur International Symposium 2021 will contribute to the development of knowledge and provide solutions to real problems in society. Congratulations on participating in the third Borobudur International Symposium 2021 agenda by reciting Bismillahirrahmanirrahim. I officially open the third Borobudur International Symposium 2021. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.
ladies and gentlemen, before we move to the main session, now it's time for us to take a picture together. So please switch on your camera, get your best pose, and we'll capture this amazing moment. There will be 3 slides, so please make sure you'll prepare your best pose. Okay, the first slide, please. 1, 2, 3. Okay. Let's jump to the next slide, please. Okay. Please make sure you'll get the best pose. Okay, 1, 2, 3. Okay, thank you. And the last slide, please. Okay. Get your best pose. 1, 2, 3. Okay, thank you so much, everyone. And now we proceed to the main session for today, the seminar agenda. There are many special speakers that will give us many insight, and this agenda will be guided by Ms. Nia Kurniati Bahtiar as the moderator. But before I let her to guide this seminar, let me read her resume first. Ms. Nia Kurniati Bahtiar, she is a director of UNIMA International Relations, one of the lecturer in Faculty of Economic and Business. She also active as a mentor for business startup and super productive as a lecturer because many research grants that already have been achieved by her and also many publications that she already have. So without further ado, please welcome our moderator for today's seminar, Ms. Nia Kurniati Bahtiar. Ms. Nia, the time is yours.
Okay, thank you so much, Ms. Pristi, for the brief introduction and quite an exaggerating one. Assalamualaikum warahmatullahi wabarakatuh. And good morning to all participants, panelists, and guests. Welcome to the main session for today's agenda seminar session. Before we start to the session, let me read the netiquette for all Zoom participants for today. The first, your mic is turned off during the session unless the Q&A session. All participants are allowed to raise hand and ask the question live. We will also share the Q&A link in the chat box as alternative in asking the questions. The attendance link will be shared both via Zoom and YouTube. Please remember to fill the link for your certificate purpose. Ladies and gentlemen, as we know, the COVID-19 pandemic and its impact to all 17 SDGs have demonstrated what began to be the health catastrophe, swiftly transformed into human, socioeconomic, and environmental crisis. The third beast brought up decade of action toward climate change issues, advancing the innovation to recover our planet as the main theme for today's agenda. This conference is expected to support the UN agenda, especially on clean water and sanitation, affordable and clean energy, industry, innovation and infrastructure, sustainable cities and community, responsible consumption and production, climate action, life below water, and life on land. So for that purpose, this session will be held in total 3 hours with 5 global class panelists. They are come from UK, Austria, Malaysia, Vietnam, and Nigeria. They are all will deliver magnificent presentation, cover all areas such as engineering, renewable energy, leadership to climate change. So, for your information, this session will be held via Zoom and YouTube, so you can either join the Zoom and the YouTube, and then don't forget to fill in the attendance link. Okay, without further ado, let's start our session by introducing the first keynote speaker, Professor Michael Hardy. Good morning, Indonesia time, Prof. Hardy.
Good morning. How are you?
Fine, thank you. How are you, sir?
I'm good. It's
Are
very
you-
early in the morning here.
Indeed, we are so thankful that you are going to have live with us. I mean, with the time differences in UK. What time is it now in UK, Prof?
It's just after 2 o'clock in the morning.
Oh my God. So we are so thankful for you to join us live with here. Okay, Prof. Hardy, but before we start with your presentation, I'm going to read your CV first, sir.
Thank you.
Okay, Professor Mike Hardy. Professor Hardy is a broad chair of the International Leadership Association, founding director of the Center for Trust, Peace and Social Relation at Coventry University, where he is the chair of Intercultural Relation. Professor Hardy trained as an economics and now researcher social relationship at leadership. At Coventry, he had responsibility for strategic work in peace education and human security for the university interface and UN system. And I believe Prof. Hardy is so well known in Muhammadiyah environment in Indonesia, yeah, Prof? You are so close with Muhammadiyah because you have been several times visiting Muhammadiyah, doing some project and etc. So another Muhammadiyah university must be known, Prof. Hardy. And in 2021, his assessment of global leadership was included in the new Sage Encyclopedia of Leadership Study. His latest work, based on extended interview with global influencers, Leadership in the Time of Disconnection, focus on the evolution and transformative leadership. And it's important for peaceful relation and more purposeful organization in turbulent world. Prof. Hardy, if I have to read all of your CV, it will take time, so I'm going to only read that. So Prof. Hardy, you have 20 minutes precisely, and then we will start the Q&A afterwards. Is it okay for you?
Yes, that's fine.
Okay.
Shall I share my slides?
Yes. Yes, please.
That's fine.
Okay.
You can all see me. I think, can you hear me clearly?
We can hear you clearly, and then we can see your slide clearly as well. So
Good.
you can start, Prof.
So, it's a great pleasure to be with you today at this important symposium. And my best wishes to your rector and to your committee for organizers, and of course to you, Nia, our moderator, for facilitating. This is really important time, and I'm glad that we have a range of disciplines and a range of subjects that we'll be considering. And mine is very clear. I'm trying to respond in my research to the call of the Secretary General of the United Nations to step up at a time of great need, of great challenge, of existential threat to humankind. Many complex and difficult challenges that we face. And above all, the Secretary General has told us that we must mobilize better leadership. We must look at local actions and put them in a global context. And above all, we must work collaboratively together across the world to confront some of these changes. Now, I can't emphasize enough in this opening remarks the importance and the challenges that we face. Our main conversation today will be about climate change and the threat to humankind of our abuse of nature and the damage that we've done to the natural world. But you know also there's major threats focused upon the relationship between the great powers. We have threats relating to difference and conflict in many parts of the world. We have 70 million people on the move, migrating from one place to another, either running away from threats and fear, or moving to better opportunities. By 2030, 2040, 2050, these times are not far away, the number of people on the move in the world will grow from the levels now of about 70 million to more like 200 or 300 million will be moving. Can you imagine a number of people, rather like the whole population of Indonesia, on the move, seeking safety in other countries? And this will create huge tensions and major threats. And it's for that reason that the Secretary General is calling for global action, collaborative action, and action which can see better and smarter leadership to help work together to resolve some of these issues. So my remarks this morning will focus on the research I'm doing about better leadership and smarter leadership. My title is really about what happens after the current crisis from COVID-19 and the health pandemic that is affecting us all. Many people say that it will be soon that we'll learn to live with the pandemic and learn to live with the public health crisis. The big question there will be, what will the world be like after, beyond COVID? And I think we're facing a challenge now. We're stepping up to a crossroads between where we move into a world which is fragmented, in which we withdraw to our own nation states, our own communities, or one in which there's solidarity of humankind working together against existential threats that I referred. So I think beyond COVID, we must make a decision. Do we want a more fragmented world, or do we want one that's more solidarity focused? So when it's all over, what kind of world do we want? And my theme this morning is very much on these three major issues. We have a choice to change and adapt the structures under which we work. We can create the Sustainable Development Goals, we can revise the international organizations, we can have a stronger United Nations, we can have more treaties, we can have more collaboration. But actually the focus needs to be on the way we behave. And culture, not structure, is likely to be more important in the future than in the past. And thirdly, my call is that in this new world of post-COVID, in this new world of challenge and change, let's be different. Let's think more carefully about our approach to rules. Let's look in more diverse places as to where we can find strength and inspiration. Let's raise the importance of empathy, of thinking about the challenges and risks facing other people. And let's reintroduce the notion of compassion, that all our faiths in many different religions point in the same direction. Compassionate collaboration will be important in the future. So what's really going to matter? I think we're going to have to prioritize, and we're going to have to prioritize against the new needs that exist. We've seen during the public health crisis of coronavirus, COVID-19, that the experts, the scientists can help the politicians, can provide the evidence, can provide the guidance from science. And that will be critical also with climate change and with the issues of the movement of people. But we need new leadership that can accommodate expertise, that can work collaboratively. And I have to tell you that for the main part, our observations of the quality of leadership in the world are very disappointing. We see leaders who look at the short term rather than the long term, and we see leadership that looks at its own communities, its own nations, before some of the challenges facing the world as a whole. And this comes down a lot to our problem with the issue of trust and our difficulty of trusting each other, whether that's within our own communities, or whether that's between nation states, or whether that's across the world generally. So what matters? My first question. I think three things are important, and my work is focused on these. Firstly, leadership matters, and I'll say a little bit more about what I mean by better leadership and smarter leadership. And you'll notice I use the word in English, leadership. I'm not talking about leaders. I'm not talking about individual leaders. I'm talking about a practice, a process of leadership where we mobilize whatever people and resources and teams are necessary in order to deliver the outcomes we want. Secondly, relationships matter. How we relate one to another is critical for the way in which we manage the challenges that we face. How we relate to nature has been critical in the damage that we've done. We haven't related very well, very positively. And of course, the major challenge facing the world is how we live with people we don't understand, that are different to us. How we live with people who have a different belief sets, different cultures, different languages. Relationships and positive relationships are really important. And finally, we know also that connections matter. The world is a very small place with very low cost air travel. Before COVID-19, we had a mass transit around the world, very easy to reach other places. And of course, in the digital world, the internet and mass communications make our connections very easily. But just as better connections are important, they also raise the risk levels and create vulnerabilities. So we have to manage leadership and get better and smarter leaderships. We need to manage relationships and look to positive relationships, mainly based on trust. And we have to look at connections and not assume that connectivity is always a good thing. So leadership matters. Let me focus here. Better, smarter leadership is a critical factor for human flourishing. And it's why, in the Secretary General Guterres' words, it is his priority. We need to develop relationships in the world that enhance the very best leadership practices. When we have better leaderships, societies can begin to address many of the contemporary challenges that I've referred to. But often, as you know, it's easier for me to point to you to bad leadership than it is to find good leadership. In this 21st year of our 21st century is a very anxious time. So what does better and smarter leadership do for us? Why is it so important? Well, leadership has two main functions that are critical. The first, leadership helps us to make sense of the complexities that we face. How do we understand things? How do we know the costs and the benefits? How do we make sense of all the mess that appears to exist in this complex and turbulent world? That's the first part of leadership. Leadership must help and enable us to understand risk better and to make sense of the complexity. Complexity won't go away. So we need to try and get close to it and understand it. And the second role for leadership is to help make a change, a positive change, to convert the impossible into the possible. So those two things, bear in mind as we move through my remarks, that better leadership must focus on helping us to better understand the complexity we face. We need better information, better communications, and a clearer strategy for the longer term. And smarter and better leadership will help make the changes that we know are important. In my research, I've found 8 characteristics of better leadership, better, smarter leadership. And it's something that I hold up to measure against the leadership that emerges in various scenarios and contexts. First, do we have a leadership that asks the right questions? Often it's assumed that leaders and stakeholders know the right questions, but leadership's relationship with expertise requires the right question to be asked. In change contexts, this is not always necessarily the case. Asking the right questions is the key to getting the right answers. That means that best leadership has got to be informed, intelligent, knowledgeable. That's not in one person, but in a team of people, where you have a combination of authority and expertise. Secondly, better and smarter leadership must work with complexity, must not be scared of things that are really complicated and difficult. Solving one problem very often in a complex world creates another problem. These are called wicked problems, and there aren't simple solutions. We shouldn't look for technical, simple solutions. We should look for adaptive solutions to complex challenges. Thirdly, good leadership is governance that cultivates trust. So a good leadership is one that believes in the relationships that it creates. Trust comes from integrity, from transparency, from inclusivity, and from predictability. There are many different characters. When your leadership focuses on trusts, they will behave in a transparent and open way. We see a lot of good examples. And fourthly, smarter and better leadership has to be more agile, has to be quick to adapt, quick to change directions when it's necessary, and very adaptive to change. Fifthly, smarter, better leadership has got to be committed to continuous learning, to continually challenging the knowledge base that they have, and has to engage with the whole. It's no use looking at part of the problem. You have to look at the whole. The big picture matters. So better, smarter leadership is leadership that makes sense of the big picture and makes changes at the big level. So just because we want to stop the destruction of our rainforests in order to protect the changes to our climate, we must also look at the livelihoods of those who want to destroy the rainforests. They have families that they need to feed. They have a local economy that they need to support. So simply stopping the destruction of the rainforests without sorting out the income potential for communities that live there and require that, it's a wicked problem, and it requires us to govern for the whole rather than for parts. Very important with leadership is my seventh point. We have to learn how to manage the loss that's associated with change. Change isn't always a win-win. We don't always have benefits when things change. Very often, there are winners and losers. And we have to focus on the losers. We have to focus on loss, because from loss comes resistance, and that causes dislocation and disruption. And finally, better and smarter leadership must mainstream the relationship between local and global. We can no longer live on an island, however attractive that sounds. We live in a complex, interdependent world, and we must become joined up and take our local responsibilities to the global stage. So the qualities in my research have been to see that better and smarter leadership is characterized by a number of characteristics. A non-negotiable commitment to an ethical approach. Ethics matter. Doing the right thing in the right way because it's the right thing to do is important for leadership. Not something that's expedient or that's economically beneficial, but something that's right, that's ethically right. Secondly, better and smarter leadership that follows those qualities will be inclusive, will listen and hear all conversations, and will represent as it can all stakeholders. Very often we'll find the solutions to our technical challenges come from very surprising places, and we must be open to a variety of alternative views. Fourthly, We live in a complex demographic. The world has young and old, men and women. We have to be multi-generational in our solidarity I called for earlier. It's no use saying that the old experienced generation must take the lead and allow the young generation to wait until the future. Nor is it the case that we should hand over everything to young people. It's actually the combination of all generations that must take responsibility, what I call the now generation, not the old and the young, but those that are working together now, multi-generational solidarity. And the best and smartest leadership that I see in my research is defined by questions, not by answers. It's a leadership that is prepared to be humble and ask for help, rather than one that's arrogant and seemingly knows all the answers. There are 4 big questions left for social sciences, and during the conference and the symposium, let's think about how scientists and the academy can help leadership by making more study of key areas. The 4 big questions. The first is, I said that good leaders had to be able to manage complexity, but we don't really understand complexity enough. We need to study complexity more and the adaptive systems that are created, that are sponsored by it. It's no doubt that most challenges have many dimensions. We're used to, in science, taking very linear approaches to solutions. We start at position A and we arrive at position B because we apply technical solutions. Complexity is not like that. Complexity means that we might have to go in multi-directionals all at the same time. And the more we adapt to one challenge, we might create others. So we need to understand that better. Secondly, we need to understand power better and what it is and who has it and how do we distribute it? How do we empower other people? How do we transfer power from those who have it to those that can make better use of it? We have to understand that. It's not enough work has been done in the academy at understanding power. And we have to look more carefully at the possibility of a solutions base. Technically, we have to be prepared to develop solutions, broad-based solutions, and think in terms of solutions. And in this, the Sustainable Development Goals are a very good example. 17 goals which are based on solutions, on better outcomes, but very complex journeys that will have to be taken. And fourthly and finally, the question about empathy that I mentioned earlier. We don't really understand how difficult that is, how difficult it is to understand somebody that you disagree with, to understand someone that you might dislike or that you've never met. How do we put ourselves in other people's shoes? We need to learn that, and we need to learn how to collaborate in a compassionate way. Think better of our neighbor before we think worse. And these are things that we don't do well and we don't understand well. I'd like to finish with...
Okay, it's 2 minutes to go. So sorry, sir.
Okay, I'm going to finish on the slides. That's all right, Ria. My final comment about trust. And this is a really interesting analysis that we're beginning to do, to think more about how trust can help with better and smarter leadership. If you were to take the standard work on trust, which is on the horizontal line here, between outgroups, as we call them, these are people that we don't really understand, we don't come in contact with, they may be in foreign countries, they may have a different value set, eat different foods. We have very low trust at the moment with people that we don't know well. And yet at the other end, we have a very high trust with people that are like us, live in our communities, in our neighborhood, talk our same language. That spectrum of trust we have to work at as leadership. We have to move people from the outgroup position to positions of high trust. And we have to think how we do that. At the same time, there's operating a vertical trust between individuals and institutions, maybe between citizens of Indonesia and the government of Indonesia. How much trust is there between people and their governments? Well, there's a spectrum there between people who feel very excluded and marginalized and people who feel, very valued and engaged. And that intersection between horizontal trust and vertical trust is a real pointer at the sort of leadership that we want. And the different quadrants define. If you have very low trust between people, but very high trust with government, that's normally associated with a dominant elite, a top-down government that tells people what to do. What we're after is, of course, the yellow quadrant, in which we have high levels of trust between you and your government, you and your international community, and high levels of trust between you and other people. In that environment, you have high participation levels, high levels of engagement, better leadership, smarter leadership, and better prospects for the future. So thank you very much for the time you've given me. I've looked at leadership beyond COVID. Are we going to be in a fragmented world or one which works together? Thank you.
Thank you, Prof. Hardy. What is such a wonderful closing you had, Prof. Hardy. Thank you so much for a magnificent presentation. So, ladies and gentlemen, Prof. Hardy has told us about beyond COVID, solidarity and fragmentation. What he mentioned is about what do we need more and new, what change in leadership he has mentioned also. What matters, like leadership matters, relationship matters, and connection matters. Prof. Hardy also told us that we don't need a better leadership, but we need better leadership and the smarter leadership. And also, in the end of the slide, Prof. Hardy told us about the trust matrix. How can a leader or the leadership that can move people from the out group into the in group? So thank you so much, Prof. Hardy. But before you go, Prof, I have some question here for you. I've got two questions at least listing here. The first one asking about you are talking about the leadership and the new thing about that in the complex industry. So what about the important character of the leadership that we have known, like integrity, self-motivation, and strong communicator? Will it be like changing about that one, Prof? That's the first question. Are you going to like answer first, and then I give you the second question?
Well, yes, so it's really important to look at our definitions of leadership. It's not always helpful to define leaders by their characteristics or their traits. Let's define leaderships by what they achieve. Let's look at the outcomes of the results. Of course, better leaders have to be good communicators, have to be honest and transparent. They have to, all those qualities won't change. But I want to focus our attention away from the type of leader to what the leader achieves, what he produces or she. What are the results of their work? That's how we define leadership.
Okay, so not only about the character, Prof, yeah? But what do you mention before? There are like 5 points that we have to know, and we have to be the better and smarter leader. And then this next question, Prof. Hardy, I'm so sorry, this is quite out of the topic, but actually Miss Ika Mardianti Agustin want to ask from Universitas Muhammadiyah Gombong about the COVID-19 has many impact in the whole world. What about the effort to achieve SDGs in this condition? How to balance the economic sector and reduce the number of COVID, especially in your country, in UK, Prof? Maybe you have a brief explanation about this one.
So we have a real challenge, and I have to say that in my country we have currently a real dilemma between our focus on keeping people safe and fighting the virus, and a focus on keeping people income and their jobs and industry. And this is the major dilemma. But I have to say that the real challenge for the world is how the global north supports the global south in the in the export and making available of vaccines. So at the moment, my thesis about fragmentation and solidarity is best exampled by the performance of the global north, which has not been very good. So you have in sub-Saharan Africa a 5 to 6% rate of vaccination, of first vaccination, and 80 to 90% in my country. And the issue with COVID-19 is it will not see the difference between a rich country and a poor country. We have to solve it together.
Indeed.
And it's a very good example. So thank you for the question from John Bong.
Indeed, thank you. Have you been to Gombong, Prof. Hardy?
I have, yeah. I'm very fortunate. Yeah.
Okay, I hope next time you
I
can
lived
visit.
in Indonesia for nearly 5 years, and I visited as much as I could.
Indeed, indeed. Can't wait for your next visit, Prof. But before that, Prof, I think the questions keep coming for you, and then we have still like 3 minutes to go. Can I ask another questions? Okay. I'm so sorry for all the participants who has been asking question in the form. We only picked the last question because of the time limitation. This is from Bita Gastia asking about how is the relationship between public trust and culture. Often the obstacle is the cultural factor, which makes people not paying attention for the danger of COVID-19.
This is really interesting.
Indeed, indeed. Please, sir.
The consequence of low levels of public trust are that when the government asks people to behave in a certain way to keep people safe, they simply don't listen. So we have a problem in the United Kingdom at the moment where the levels of trust in our government are very low, historically very low. And as a result, we worry that people won't listen when the government gives good advice, and it's selective. So we have to be really careful about levels of public trust. They are really important, and governments must take seriously the responsibility they have for providing open and transparent guidance to their people, and to follow the scientists, follow the doctors. And we see some good examples. But culturally, the final point I'll make, Nia, is really interesting. Some cultures are more compliant than other cultures. Some peoples in different countries behave differently. So if you take the results from South Korea, in the management of coronavirus in South Korea, some people will say it's more successful because the people of South Korea are more compliant. They will wear face masks more systematically. They will protect social distancing and so forth. Whereas in parts of the United States, you may well have read, particularly in the southern states, there's been real resistance to face masks, real resistance to stopping having parties. And as a result, COVID has spread very widely. So there's a cultural relationship between compliance and adherence to advice.
Oh, wow.
Very hard to generalize,
so
though.
it
I'm
has
just
a
giving
very
examples.
strong relationship, Prof. Hardy, regarding this. And then I believe I agree with you that different country has got different approach in also facing the crisis. Thank you so much, Prof. Hardy, for your explanation. And absolutely thank you so much for joining us live due to the time differences. I believe it is like 2 a.m. in the morning, and then you're still with us today. We would like to say thank you so much, Prof. But because we have to move to another session, we would like to say thank you again once more time, and then see you in another occasion, Prof. Hardy. Good morning, UK time,
Soon,
Prof.
yeah.
See you,
Bye.
Prof. Ladies and gentlemen, that was the first speaker, Professor Michael Hardy from Coventry University, United Kingdom. Now we are jumping to the next speaker, Tony Hadibrata, PhD. Pak Tony, apa kabar?
Alhamdulillah baik.
Alhamdulillah. Terima kasih sudah bergabung sejak pagi, Pak Tony.
Ya, sama-sama.
Okay, because this is like international conference, I'm going to conduct it in English. Is it okay, Prof?
Yes, please.
Okay, but before that, I'm going to read the CV for Dr. Tony Hadibrata, PhD. 1 minute, let me share the screen. Okay. Dr. Tony Hadibrata, Associate Professor in Faculty of Engineering and Science, Kartini Universities, Malaysia. Head of Bioprocess and Technology Research Culture from 2018 to now. Program Coordinator of Master of Sustainable Aquaculture from February 2020 until now. And also, the education of Professor Dr. Tony Hadibrata, PhD in Environmental Chemistry and Microbiology, and how can we say this? Ehime University? Udah bener?
Yes, correct. Ehime University.
Ehime University, Japan. And also, MSc in Environmental Chemistry and Microbiology, Ehime University, Japan, and then BSc in Universitas Mulawarman, Indonesia. His research interests cover environmental chemistry, environmental microbiology, engineering, biomediation of toxic pollutant, water and wastewater treatment, and microbial enzyme. I cannot explain all of your Scopus publication, Dr. Tony, because it gets too many publications in Web of Science. He's got 130 publications, and in Scopus, he's got 147. Mention is quite tired, I believe, as like Dr. Mujib has mentioned before. And then you've got scholars like 150. This is another publication and intellectual property that Dr. Tony Hadibrata has got, and then professional activities and so on. So, Dr. Tony, without further ado, you have 20 minutes for the presentation, and after that we have Q&A session. Okay, Dr. Tony, the time is yours.
I will share my screen.
Okay.
Can you see my screens?
Yes, properly.
Okay. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh, and very good morning.
Good morning, Dr. Tony.
Very good morning for the committee, the speaker, and participants in the wonderful conference. Firstly, I would like to thank to Universitas Muhammadiyah Magelang, especially Prof. Muji, for inviting me in this conference, symposiums. And today I am very happy to share with you about my research, the topic involvements of the lignolytic systems of fungi in biotransformation of emerging contaminant. Okay, this is the background. As we know that water is very vital to human life and fundamental to all developments. Access to clean water has become a major concern as water is necessity for all socio-economic activity. In Malaysia, we have 566 billion cubic meters fresh water, as well as 64 billion cubic meter groundwater. We have 90% of water supply come from the surface water, but unfortunately, we have still 10 polluted river as well as 49 slightly polluted rivers. You can see from the graph, there is no developments to reducing the polluted rivers. In 2013, we have 10 polluted rivers. Now, 2019, still remaining 10 polluted rivers. The polluted rivers come from the point source, the sewage treatment plants, manufacturing, agro-based industries, as well as animal farms, and also the non-point source agriculture activities, plantation, and surface runoff. Okay. The problem is in the wastewater treatment industry, especially the treatments, mostly in Malaysia, wastewater treatment plants still using the conventional treatments, and these conventional treatments showing the high operationals and maintenance costs. But the problem is these treatments can only effective to reduce or eliminate BOD, COD, the TSS, EDS, EH, and so on. But these treatments cannot be effective to remove emerging contaminants. So I will explain later what is the emerging contaminants. Here in the table, we can see some wastewater treatment plant in Malaysia with the advanced treatment systems, but we can see the reducing of the emerging contaminants still less than 20%. Yeah. You can see from the Sungai Besi treatment plants using the activated sludge as well as the oxidation ditch, only 19.5. Yeah, the lowest 6.3 in the South plant. So because of this reason, we have to provide the effective treatments to reduce the emerging contaminants in the wastewater treatment plant. Okay, this is the emerging contaminants. The emerging contaminant is the pollutant that's the unregulated yet by the governments. So we don't have any regulation to manage these limits of contaminant in the aquatic system, aquatic ecosystem. These pollutants already in environments, such as the pesticide, pesticide dioxins, flame retardants, the phenols, the PCB, the estrogens, and pH. And in this slides, I will explain how the fungi can degrade the pH. The pH is the compounds containing minimum 2 benzene ring. Yeah, this is the benzene rings. So minimum 2 until 6 and 7 benzene rings. Yeah, this is quite difficult compound to treat and also to degrade. The Malaysia has issued a green technology master plan. There is 6 sectors: the energy, waste, industry, construction, transportation, as well as water. And our projects align with the water sectors. In the water sector, there is a 5 approach, and we try to fulfill the wastewater treatment technology sector. Yeah? Here, there is a preventive and curative. For curative, we try to contribute in the bioremediations and effective microbes to degrade the pollutants. So now our project is aligned with the SDGs by United Nations, especially goal number 6, clean water and sanitation, to propose environmentally friendly approach. Yeah, this is very important, environmentally friendly approach that improve water quality by reducing pollutants, eliminating dumping, and minimizing release of hazardous chemical and materials, targeting affordable drinking water by for all by 2030. As well as the goal number 14, life below waters, to prevent the releasing of emerging contaminants into the aquatic environments caused by the ineffective water and wastewater treatment plant. Okay, this is the situation in Southeast Asia. As we know that the Southeast Asia is the hotspots of the biodiversity. We have a lot of tropical forests, mangrove forests, peat forests, and a lot of diversity of animal and plant. Yeah. In 2015, we have in the Southeast Asia, we have 206.5 million hectares of forest, from various types of forests. But the big issue here is deforestation. Yeah? You can see from the graph that the increasing of deforestation in Indonesia as well in the rest of Southeast Asia. So because of that, we have to to protect our biodiversity, especially the non-wood product from the forest. This is the situation in Malaysia. I'm living in the Sarawak. Yeah? Here, the biggest states in Malaysia, around 30% of Malaysian area, and in Sarawak has more than 800,000 hectare protected area, national park, wildlife, and natural reserve. And in the forest, we have the wood and non-wood. For wood products, of course, the wood will be produced to become the plywood, the furniture. Yeah. For non-woods, we have the fruits. Yeah. Also the microbes, the fungi. So in this case, we try to explore more what kind of fungi that can be utilized to remediate the pollutants. Okay, this is the utilization of mushrooms in the biotechnology. There is 4 aspects here. One is for the pulp, paper, textile industry. as we know that mushrooms or fungi can be used for the biopulping process, the conventional process using the chemical. And now we are trying to convert the conventional chemical process using biopulpings by using the microorganism, and as well as the bio bleaching of the pepper. The second, for the industry, food industry and animal feeds, the microorganism can be used for the brewings and the reproductions by using the amylase and proteases enzymes. The third, biofuels and biocatalysts. These microbes can be used for the fermentation process by using the cellulose enzymes. And lastly, the environmental management. Here, to protect or to remediate the pollutants using some enzyme here, the leachase, phenol oxidase, peroxidase, and phytase. In this research, I tried to explore more on leachase as one of more powerful enzymes produced by the fungi. Okay, this is for the informations. The Basidio macetus fungi, mushrooms, basically they categorize into three types: the white root fungi, the round root fungi, and the soft root fungi. For the white root fungi, this fungi can break down the lignin in the woods. So if you see the decay woods, the color of decay woods white, then the white fungi play a role in these deteriorations. As well as the brown root fungi break down the hemicellulose and cellulose that form the wood structure. So if you see the color of the woods, the decaying wood is the browns. So this is the important role of the brown root fungi functions. And for your information, what is the lignin and cellulose? So the wood component, wood basically consists the lignin and cellulose. Cellulose is the fiber, the fiber. The lignin is like the glue, the binding of the fiber. So for the pepper industry, we need the cellulose, but we don't need the lignin. We will remove the lignins from the wood component. So in the pepper industry, pulp and pepper industry, the pepper, as you can see, is the fiber. So in this case, we try to degrade lignin. So it means if the fungi can degrade the lignins, so we assume that the fungi or mushroom also can degrade the pollutant. Why the fungi can also degrade the pollutant? Because the structure of the lignin, we can see here, this is the structure of lignin. The coniferyl alcohol, sinyphyl alcohol, and parachromyl alcohol. We can see there is a benzene ring here, benzene ring here. And most of the polycyclic aromatic hydrocarbon consists this kind of structure. So we assume that the fungi can degrade the lignin component, can degrade the organic pollutants, especially the aromatics pollutants. This is the enzymes produced by the fungi that we know. We have the oxidoreductase, transferase, hydrolase, lysase, isomerase, and ligase. And this is the functions, how they degrade the pollutant. But here there is three important enzymes: oxidoreductase, transferase, and hydrolase, especially the oxidoreductase. This is most common enzyme produced by the fungi for bioremediation of pollutant. This is the lignin component. As my previous explanation, the lignin is component of food. So the lignin can be degraded, can be transformed using the three main ligninolytic enzymes. First, the lignin peroxidase, the leachase, and manganese peroxidase. And this is the concept. The lignin peroxidase, of course, they are using the peroxidase here. The leachase using the oxygens, and the manganese peroxidase using the hydrogen peroxides in the helping with the manganese ion. So we are focusing on leachase because we just use the oxygens as the mediator. Here's the concept of the enzymes transformations. So the leachase will be oxidized by direct oxidation or indirect oxidations. Indirect oxidations, the leachase oxidized leachate will transform the substrates into the oxidized substrate. Yeah. Of course, the substrates, the toxicity of the substrates is more than the oxidized substrate. Yeah, because our target is to reducing the toxicity of the pollutant. The second one, the indirect oxidations, we need the mediator. Mediator here need to be oxidized to be the become the oxidized mediator, and this oxidized mediator will transform the substrate into the oxidized substrate. So this is the two types mechanisms of leakage in the biotransformations of the organic pollutants. Okay, this is the screening. Yeah, we have to screen or isolate the fungi. Yeah? We select fungi from 5 national parks: yeah? Bako, Nia, Simalaju, Lambir, and Piasau. So from all of fungi, we have 804 Basidio measures of fungi, yeah? From the wood decay, soil, leaf, and others. Yeah? Then we isolate using the malt extract agar, and then we culture it, and then we put the indicator. The indicator is poly R 47X, RBGR, Rimazole Budan 2R, Guaiacol, and single decim. This mediator, why we have to use this mediator? With this indicator, because this indicator contains some dye, some color. Yeah? So if the fungi can decolorize the color, it means the fungi will produce the specific enzymes that I have explained previously. And then we screen the fungi and identify with the microscopic, and PCR if possible. And this is the picture of the fungi, the mushrooms that collected from the forest. We collect 2 times, yeah, during the wet seasons and the dry season. Yeah. In the wet season we get 459, and dry season is 300 something species from the forest. Yeah. Then we characterize, then we get that the fungi is 18% saprophytics, and then 10% mycorrhizals, and 28% is parasitic, as well as the 19% edible, and then the medicinals is 24%, and inedible 38%. Then we identify here, yeah. After checking with the indicator, yeah, we have here the response, yeah. There is a less than 30%, 30 until 60%, 60 until 90%, and more than 90%. Our targets, the fungi must show the reaction more than 90%. Yeah. So we get only 3. Yeah, we get only 3 fungi: yeah, BM172, BM745, and BM792. These fungi categorized as the saprophytics and parasitic fungi. Okay, then we identify the fungi using the microscopes, checking the observing, touching, smelling, tasting, and then the microscopic, the size, the shape of the spore, also the arrangements of the spore. And if possible, we try to check the PCR amplified part of 18S RNA genes, yeah, using the universal primers. Then this is the result, the name. So we get the name of 172, Coreopsis caperata, 745 Fomes fomentarius, and 792 is Pletius cisopaius. The genus, the genus or the order of the family, the fungi is Polyporales and Agaricales. This order of fungi commonly used as the fungi producer for biodegradation of organic pollutant. Okay, and then after that, after we get 3 best fungi, we try to culturing in the liquid media. Yeah? This is the flow chart of the experiments. We culturing Pseudomonas extra agar incubated in the room temperature 25-30 degree, and then after that we extract the liquid culture.
Dr. Tony, I'm so sorry. You still have 3 minutes to go.
Okay, yeah.
Okay, so
okay,
sorry.
thank you very much. Okay, this is the thank you very much. This is the extractions, yeah. So our target to find the metabolites, yeah. Our target is to find metabolites. This is the mechanisms, yeah. So we try to degrade the pollutant into the small or the simple structure. So we try using the GCMS, FTIR, the melting point, UCR, and also the thin layer chromatography. And this is the effect of carbon source in the leachate productions as well as nitrogen source in the leachate production, that the leachate proved to degrade 3 pH, yeah, 3 pH, but the mechanisms, is this the degradations can be biosubstance or biotransformation? If biosubstance, the pollutant only absorbs to the fungal body, the structure of the pollutant remaining same. So we just moving the pollutant from the liquid culture to fungal body. Yeah, our target is to make a biotransformation. This means the structure of the pollutant will be degraded into the small or simple structure that the toxicity level is reduced. Yeah, is reduced. That's the target of the biodegradation. And we can see here, phenanthrene, anthracite, and pyrines produce the metabolites. Yeah, you can see here the penic acid, hydroxynitric acid, catechol, salicylic acid. That if we check, these compounds has less toxicity than the parent compound. Okay, this is the mechanism. So maybe I just give a brief explanations that in the pH there is a B region and K region. Basically, the transformation will occur here, yeah? The K region and B region. So we can see after several times the fungi can reduce or degrade, transforms the structure here into the simple structure. Yeah, this is the case of phenanthrene, as well as the anthracene. Yeah, from here 3 rings, benzene rings, yeah, become the benzoic acid 1 ring. Yeah, reducing the toxicity, as well as the pyrene 4 benzene rings become the 2-hydroxy benzoic acid and the phthalic acid. Yeah, 1 benzene rings. So the toxicity must be reduced. And the problem is the enzyme cannot be implemented into the environments directly. Yeah, we need the materials. By immobilization. This is the technique of bio immobilizations. There is a cross-linking, adsorptions, entrapment, and covalent binding. So yeah, I will not explain this type of immobilizations because this is too complicated. Yeah, and we hope that our project will give impact to the governments for the significantly to the Malaysian water efficiency, yeah? And then the community, the academia, by using the new technology of enzymes, the environments, yeah? Improve water quality, as well the industry. We try to commercialize our products into the prototypes, yeah? To be more easily implemented in the environments. And for the conclusions that microbial degradation is effective alternative treatment, yeah, for emerging contaminant. And from the 3 type of fungi, but the fungi proved to be the most efficient lignin degraders as well as the emerging contaminants degraders. And we also proved that the emerging pollutants is transformed, yeah, has been transformed into the simple structure that having low toxicity and less danger. And finally, the enzymes need to be immobilized before the implementing into the environments, yeah, in situ treatments. Okay, and this is reference that I use in this slide. You can see, yeah, you can read in the here. And thank you very much for your kind attention. Let me know if you have any questions, so I will be back to the moderators. Thank you.
Thank you so much, Dr. Tony Hadibrata. Such an impactful presentation that you had before. Terima kasih banyak Pak Tony, tapi standby dulu Pak, masih ada pertanyaan abis setelah ini.
Yes.
Okay. Dr. Tony Hadibrata, ladies and gentlemen, started the presentation by telling us the problem about the pollutant affect the water quality and the wastewater. And then he mentioned also about the green technology master plan included energy, waste, industry, construction, and transportation. And then he actually briefly introduced us to his project, yeah, that relate to the goal number 14, if I'm not mistaken, Dr. Tony?
Number 6 and number 14, yes.
Oh, number 6 and number 14. He's talking about how is the biodiversity used in various industry, start from pulp, textile, food, until the biofuel. And then also, Dr. Tony has tested the fungi resulted direct in indirect oxidation, and then telling us that there is effective alternative treatment for emerging pollutant. There is also most efficient lignin in nature. And lastly, he also said that the lacase enzyme is playing a key role in transformation the emerging pollutant like that. Okay, wow. You've got quite question here, Dr. Tony, about the presentation that you had. So ladies and gentlemen, if you have any question, you can both raise your hand and you can also fill it in the link. Okay, I have the first question here, Dr. Tony, asking about this one. You are mentioning about the deforestation as the challenges. Okay, if it matters, do you have or do you think of any alternative that we can use to reduce pollutant in the future? So, should I give you one question first and then the other question after you answer? Is it okay?
Yeah, okay.
Okay.
Okay, so the question is actually we try to save the biodiversity. Yeah? One of the biodiversity is the microbes, the fungi. Yeah? Because when we are talking about forest, we are focusing on wood products, right? Wood products, yeah, like to become the plywood or furniture or something like that. But we have forget about the non-wood products, and one non-wood products that we almost forget about the fungi or mushroom. We just eat the mushroom, yeah. We just eat the mushrooms as the food product. So we try to give the other perspective that the mushroom also can be utilized as the biodegrader, yeah, biodegrader, especially for the pollutant, yeah, for the pollutant. Yes,
even though the deforestation become the challenges like that, Dr. Tony?
Yeah, the deforestation is challenges, but we try to give the solution. Yeah, solution is not the how to stop the deforestation. Yeah, that is not my background, but I am proposing the alternative solution to save the biodiversity, by utilization of the mushroom.
Okay, thank you, Dr. Tony. I hope the participant who asked the question can understand well about the explanation. Now, Dr. Tony, we have somebody has raised hand from Mr. Tukina from BINUS Jakarta. Can you please unmute yourself, or the operator, can you help to unmute Bapak Tukina? Okay, can you please open your video? So.
I will to ask. Sorry, I on off cam because of any trouble. I have I use handphone again,
okay,
so not familiar.
No problem. You
my
can
question
say
to
your
Professor
questions.
Tony. Okay, my question, Professor Tony. I interesting your presentation, but in Indonesia, is big country, is many problem about deforestation, the pollutant and so on, and water problem and so on. How in Indonesia, especially in Jakarta, on the Solo, and the big city, others, how you can suggest about simple policy where that policy accept society and simple to realization and make situation as good. So not complicated, because if any policy is any one of the people is accepted, the others is unaccepted. This is and pluralist and many people of about of amount of 73 billion people in Indonesia. And this is how with your interesting presentation can real in Indonesia. So then thanks very much.
Yeah, thank you very much for the
Thank you,
question.
Pak Tukina.
Yeah, I try
Dr.
to help.
Tony,
Yeah,
please.
okay. I try to answer it. I hope I can get the correct answer. Yeah, the important thing is for waste management is preventing waste into the environment. That's the best thing. So we don't to release waste into the environment. So no waste in the environment, no treatment. That's the important thing. If you're asking me how to treat that kind of waste, then I will provide some approach here. But if the important thing is don't release the waste into the environment. Yeah, don't release the waste into the environment. The preventive way, preventive methods. That's the important thing. Yeah. If the waste already released to the environment, then we try to treat, and the cost of treatment is higher than cost of preventing. Yeah, that's the concept. The cost of treatment is higher, much higher than cost of the preventing releasing waste to the environment. So that's simple. If you're asking me about the BCT, yeah, the community, the governments must follow the rule. We have rule, right? We have the undang-undang that don't release the waste into the environment. That's the rule, but we don't follow that. You know, right?
Okay, thank you so much, Dr. Tony Hadibrata, for the brief presentation and also the answer for the questions. We are so sorry, Dr. Tony, there is questions, but the 30 minutes time has already passed. So we would like to say thank you so much, Dr. Tony, for your time and also knowledge given, and then very interesting finding that you have. And then we hope to meet you in another occasion, Dr. Tony. Okay, thank you so much. Have a good day, Prof. Tony.
Yes, thank you very much.
Thank you. Okay, ladies and gentlemen, we are so thankful for all the questions that you have in the link that you have written and also you have been asking so far. Keep on going with all the spirit you have in this symposium because we still have 3 other speakers that are going to discuss various and also interesting things with us. And then we will welcome you, the 3rd speakers, Dr. Rahmat Adi Wibowo. Selamat pagi waktu Indonesia, Dr. Rahmat.
Alhamdulillah, selamat pagi. Assalamualaikum semuanya.
Waalaikumsalam warahmatullahi wabarakatuh. What time is it there in Austria?
It's I think 6 hours difference now actually because this is winter, normally 5.
Oh, okay. Is it
so
early?
it is now it's almost 5.
Oh my God, thank you so much. Bapak Rahmat sudah menyempatkan waktunya live presentation with us today. We are so thankful for that. But before that, Bapak Rahmat, saya akan bacakan CV-nya dulu. So ladies and gentlemen, I'm going to read the CV of Dr. Rahmat Adi Wibowo. He is actually in Austrian Institute of Technology in Austria, field in photovoltaic technology, and then main research in emerging technology. Dr. Wibowo has intensively been working of the scientists of earth-abundant casterite. Is it how you say it? Casterite like that?
It's casterite or something.
Casterite.
Sometimes people also say casterite, but it's no problem.
His current research activities are developing novel approach of high throughput casterite fabrication process using solution-based process. And then you can see here, he has been a research professor in South Korea from 2008 to 2008 to 2009. Research fellow in Singapore, Nanyang Technological University, and has been to Germany. You've been flying a lot of ways around the world. And then the last, 2013 until now, scientist in AIT, Austrian Institute of Technology, Austria. So, Dr. Rahmat Adi Wibowo, because we have like time limitation during the meeting, you have 20 minutes for delivering your speech, and then we will start with Q&A. Okay, Dr. Rahmat, you want to share your screen by your own?
Yes.
Okay.
Let's see if
Okay.
if you can see my presentations. I
We
hope
can
everything's
see
fine. Yeah.
clearly. Yes.
All right. So yes, many thanks for the introductions. Thank you for having me. And I think it's still in quite early morning also in Indonesia, in Magelang, and in hometown basically. Yes, my name is Rahmat Adiwibowo. From I was born in Jakarta basically, and then I live and work in Austria since 2013 as a scientist working on photovoltaics, or if you're not familiar with photovoltaics, we call this as a solar cells, the one that convert the sunlight into electricity and becomes some kind of very popular terms in terms of low carbon technology, renewable energy, and so on for generating electricity in the future, let's say. And for someone who has not been to, let's say, in Austria and Vienna, so this is our campus here, the Austrian Institute of Technology, for your informations, perhaps, yeah. AIT, or Austrian Institute of Technology, is the biggest or the largest research institute, non-academic, non-university research institute in Austria. So basically we are, in Indonesia, I think we are comparable to BRIN, B-R-I-N. And since this is winter, so you can see the beauty of the the winter atmosphere in Vienna.
Beautiful.
So let's see if we can meet somehow or sometime there. Yeah. So just to go directly to the core of my talk today. I'm sorry why it's the presentation moves by itself. All right. So just introducing you a short, brief activity in our laboratory. So basically, we are developing something. We are material scientists, we are physicists, we are chemists, we are software programmer, and so on. In our group, we develop materials for a solar cell or for photovoltaics based on elements which are abundant in nature. So basically, a lot of materials, technological materials consist of rare earth and so on, but we are interested in developing of the solar cells or photovoltaics based on abundance material. So this is one of our recent publications, just published 2 months ago, about how to design a new type of a solar cell, which can be discussed in the Q&A session, perhaps. The other activity, we don't make a bag, we don't make how do you call the rucksack, but we develop the components in the bag, which is actually powered by the solar cells. And you can see that this is one of the our partner from the from the startup company in Austria who develops a solar cell which is flexible and you can bend it, you can use it anywhere. So that is the concept. The other is a bit high or a bit big project is, of course, is to participate in any building integrated solar cells or building integrated photovoltaics, which uses photovoltaic integrated in the building to support the electrical power source. So you can see this is one of our our building in AIT. This is a low energy building. We don't have electricity from outside. We powered it is self-powered by the additional additional attachment of the solar cell on the wall. And this is also without any other heating systems. So basically, what I call by the earth abundant material is something like you found easily in the nature, like iron, like copper, and like zinc, like tin, and so on. And Indonesia, our homeland, actually, it's rich about these kind of the the elemental or the materials. We are, let's say, rich about copper. We have a copper mining, we have tin mining, we have also, I believe, zinc source mining, and of course another type of other materials, which is outside of this list, basically. So this is what we call the critical raw materials, which is not only scarce, not only rare in the nature, but also very highly important in terms of economical or technological. Just for instance, just for an example, so you can see here the indium, and this is in gallium, and this is vanadium, and then also cobalt, and they are really rare materials, or they are really important materials. Because of all of the competition of the product and technological product uses this kind of elements, this kind of materials, so there are a lot of competition to get it, and the price increases, and of course then the product of the technology is not really as affordable as we use the non-critical materials, I mean. So turning back to the solar cells technology, to the photovoltaic technology, there are actually a lot type of photovoltaics or PV, excuse me. So at least there are 13 or 6 types of the solar cells, but in the markets you can find at least 2 or 3. So if you see the solar cells on the rooftop, if you see the solar cells on the ground, and if you see the solar cells on the online market, let's say on online shopping, you will see the bluish solar cells. What we call this module basically contains silicon. So this is the silicon type of the solar cell, which is 90% in the market. So you can easily find this type of solar cells. At the bottom, because of solar cells made of silicon is so rigid, so you cannot make any flexible things, and the efficiency is low, and it's also heavy. So recently, in the past 10 years, the scientists working together with the industry works on the other type of the solar cells, what we call the 6. So this is the compound name from the copper, indium, gallium selenide. I'm sorry. Just to mention that this is quite a lot of complex materials, a compound here. So we normally, we just say this type of materials as a 6. So these 6 solar cells differ from the silicon solar cells or silicon photovoltaics because it is so thin, much thinner, much lighter than the silicon solar cells, so it can bend. You can bend it like in the figure, and the way to make it, somehow you can use the roll-to-roll productions, what we call it as a roll-to-roll fabrication process. So it's like rolling a plastic foil or rolling a paper basically. So this is from the 2 companies that works with us as well. So first the Sunplug Photovoltaics, who makes flexible solar cells, and then another company from the Switzerland, from the Zurich. So Flissom works also with the 6 materials to make a flexible solar cells. So you can make a lot of products powered by the flexible solar cell for sure. And then the problem with the 6, as I mentioned previously, that it contains actually the indium and gallium, which is categorized as the rare elements or critical raw materials. You can see in the graph, let's say this is a classic paper studied about the price of the elements. It is actually inverse to the production rate per year. You can see that actually the silicon is not really the price is high, but the production per ton is less. And then you can see also here, for instance, indium and gallium. So the price is really high because the mining, the production of the indium, purification, refinement, and so on are really less basically. So then we try to find or to search another type of the elements which can replace the 6 or more specifically, we can replace the indium or gallium with other elements such as zinc and tin, because the zinc and tin production is huge each year, but the price, it makes the price lower, much lower than the price of the indium and gallium, for instance. In chemistry or in materials terms, so basically we can replace the atom of the indium and gallium into, I'm sorry, just a moment, into the zinc and tin atoms. So you can see schematically in this atomic structure diagram of these molecules, of these materials basically. Then we are going to talk about the new materials, the proposed materials, which can replace the 6 as a solar cells. And we can discuss also the outlook, the promising aspect of these materials, what we call as copper zinc tin sulfide, or CZTS for short. I think this is much more relevant for Indonesia because the indium and gallium actually somehow monopolized by a certain country like the China. China is the most producer of the indium and gallium in the world. So not only Indonesia will depend on the China for that, but also Europe and the rest of the world. So this is the motivation why scientists and industry now turn to switch from 6 technology into CZTS technology. So this is, if you want to have a look about the very close into these materials, into these photovoltaics, you can see that on the right-hand side, this is the photovoltaics, excuse me, the photovoltaic cross sections from the electron microscope. So you can see the thickness of the films, the thickness of the device, the photovoltaic, is only in total about 5 microns. So here is 6 technology, and here is the proposed CZTS technology. Both have the same structure, but have a different the layer on the 6 and CZTS. So if you are not familiar with the solar cells, so the basic principle of solar cell is if you put these 2 materials on outside, in the outside, let's say, and shine with the sunlight will go into the device. The sunlight will be absorbed by the CZTS or 6, and the electron and hole separated because of the PN junction, the diode junction built between the absorber films, between 6 and the cadmium sulfide. So cadmium sulfide is N-type semiconductor, and the absorber films are the P-type semiconductor. For someone who works in the electronics, in the chemistry, in the physics, you are familiar with the PN junction. So basically, solar cell is just a PN junction, and we still need another materials for having a complete cells to extract the electricity. But in essence, the photovoltaics consist only the absorber film, the 6, and cadmium sulfide films, basically. So this is how we make it actually. So this is old paper of mine which, let's say, try to synthesize, try to make CZTS materials by mixing copper, zinc, tin, and sulfide or selenite. Let's say you can replace with the selenite as well. Mix it and heat it up until, you can see here, I heat it up until 700 degrees Celsius. And then at the end, you will have these CZTS materials. And then how we can do it, because let's say there are some chemical reactions involving all the copper, zinc, tin, and sulfide, and sulfur, I mean. And then you see this is the proposed the chemical reactions, how you can produce these materials from copper, zinc, tin, and sulfur. So you see that if you heat up until 700 degrees Celsius, let's say, you will have a lot of reactions. Let's say this is the graph of the product of the reactions between 300 degrees Celsius and 700 degrees Celsius. So basically in this graph telling you that you can make the CZTS materials at 500 degrees Celsius basically by reacting all of the elements, and then you see closely that there are stepwise chemical reactions until you get the final reaction of the copper tin selenide versus zinc selenide. It becomes copper zinc tin selenide. You can replace the selenide easily by sulfur, just replacing it, and then you will have the copper zinc tin sulfide. This is a really straightforward reaction because the CZTS material is really exothermic, so you can easily forming it into the materials that you need. But in order to make it as a solar cells, we need another technology. So first we just synthesize the CZTS, or what we call as a solar absorber materials. Then we use another technology to convert it into the photovoltaics. I just try to introduce briefly a method for making a photovoltaic device, what we call it as the sputtering. In physics department, mostly you have the sputtering systems. So basically it makes a films, like here is one of our students make these very thin films about less than 100 nanometers from the compound, from the targets of the same materials basically. So these powder materials gets into the sputtering. So the sputtering do the job, and then the sputtering make a thin films out of it to have, let's say, 100 nanometers until 1 or 2 microns. So this is the facility of the sputtering system in our group in AIT, which works almost every day, and a lot of students basically uses it. And then we try to make a lot of product out of it. So this is, for instance, just for example of the for your information. So I did this quite some time ago. I have a trouble with my mouse, I'm sorry. If I can explain this graph for you. So here is the glass. So we make a films, or the layer of materials, in this case the CZTS films, on top of glass. And the thickness of this film is about about less than 1 micron until 1.5 micrometers, basically. So I did this as a function of the temperature to see whether I can make the CZTS films. And so on. The story goes a long way until one of industry partner in Germany, they are interested in trying these materials on their production line. So it is quite fast track development until we can see the commercial aspect of this CZTS, and they try it. And then we collaborate together, and you see that we can make a CZTS photovoltaic solar cells or solar cell device by making a variation on the elemental ratio, the composition of the chemical elemental in the photovoltaic device from 0.76 until 0.8. So this is the ratio of the copper against zinc and tin, and this is the typical ratio of zinc against tin. You see there is a very short window how these materials can lead us into the high efficient solar cell. So the white area is about more than 6% efficiency. So let's say that the composition, the ideal composition of copper, zinc, and tin should follows this graph ratio. So about 0.78, the ratio between copper and zinc tin, and then the 1.2 for the ratio of zinc and tin. So this is a really detailed actually for you, but at least what the information I will try to give to you here is that we by the by adjusting, by engineering the composition of one materials, you can get the functionality of the PV or photovoltaic device. So this is the
sorry,
cross
Dr.
section.
Ahmad. I just need to
Yes,
remind you,
go
you
ahead.
have like 3 minutes to go. I'm so sorry.
Thanks for reminding. Thanks for reminding me. Yes, this is the core actually for the presentation today. So this is the cross sections of the photovoltaic device, which basically we talk always about the nanotechnology, but this is not really nanotechnology because the size of this grain or the cross section is about 2 microns. So basically, it's not really thin enough for making a nanotechnology terms for this. There are a lot of activity going on in the lab. Like you can also improve the performance of the photovoltaics by engineering or by simulating what kind of materials suitable for this. And this is our recent publication from our group. And then basically you try to improve the transparency of the top layer and so on. And then what you see is basically improvement of the efficiency of this solar cell until 8.2%. And this is one of the product. Just maybe try to explain this one. You can make this is the glass. You can deposit some materials. We call this is aluminum doped zinc oxide. The zinc oxide doped with the aluminum, and you see that by increasing the layer number, so basically you increase the transmittance or the optical transparency of the materials. This is the outlook actually. This is really in infant stage in our group. So basically, we try to apply these materials, these CZTS materials, for converting the water into the hydrogen gas. In chemistry, you call this as photoelectrochemical cells or photoelectrochemical water splitting. So you divide the water, H2O, into the hydrogen gas and oxygen gas, basically. And this is a very early result, and we are working on it, but if I would like to remind you about low carbon technology or climate change that want to reduce the fossil fuel, so this is a really interesting technology because the hydrogen produced by these techniques will replace in the future the fossil fuel, the oil, and so on. So hydrogen will replace the fossil fuel to drive your car, let's say, to drive our train and so on, even an aeroplane in the future. Then for chemists, for material science, for the physics students, I think this is really interesting topics to discuss and topics to pursue, let's say. And then let's say by using earth abundant materials, you can achieve the perspective, promising types of the technology from this. So I think we can go for the next sessions, Q&A, Mrs. Chairwoman. Then many thanks for your attentions, and I would be very glad to hear any discussion here. Many thanks.
Okay, we thank you actually, Dr. Rahmat Adewibo, for the brief and explanation. He mentioned about the early stage of the research, but before that, ladies and gentlemen, I need to remind you that you can either raise your hand or you can fill the link for the question if you have questions to Dr. Rahmat. And then the attendance link will be shared later, so stay tuned and stay with us. So, Dr. Wibowo has, I don't know how to call you, Dr. Wibowo or Dr. Rahmat, because you've been away for quite a long time. How can people call you there?
Both are wrong, actually.
Okay, both are wrong. How can we call you there?
You can call me Adi.
Okay, in the middle name, right? Okay.
Yes.
So Dr. Ade has told us about the solar cell from abundant material. It's quite interesting that you can see we have a lot of type of material that we can use based on the explanation like iron, copper, zinc. And also there is this CIGS. I'm not sure what is that, but the CIGS is actually thin and can be folded, the type of the solar cell, but it's quite rare, if I'm not mistaken, Dr. Adi.
Yes.
Okay, so because it's quite rare, you have an early research. You use CCTS, is it right? CCTS is the
Correct.
more relevant because it uses the element that we can find easily. Also, Dr. Adi has synthesized it and using another technology to convert it into the solar cell, which is like having a very thin product, like a film, right, Dr. Adia? And then that's quite impressive to have that kind in our home nearly in future. I hope so. Okay, so the question for Dr. Adi, please. Okay, wow, we have quite a lot here, Dr. Adi, and then let me read it one by one. The first one from Uta, he didn't mention the university, asking about, are you concerned about the price of the material? But it's actually a very thin film. Is it not 1,000 or million ton demand? Do you think so? Do you think it will be like affordable to people for that kind of technology that you mentioned before? So I'm going to give you one question and you can answer directly, and then I'm giving another question. Is it okay?
Right. So can I answer it directly now?
Indeed.
Yeah. Yes, thanks. So the reason why the price of elements, the price of the materials, let's say, high, is because either the demand is high, or the supply, or the, how do you call this, natural abundance, natural resources are less, or are rare, actually, rare or scarce. So this can be done like that one. So gold price is high because the high demand, but the gold is the abundant. Yeah, so you can see, you can find gold anywhere in Tembagapura, in Papua, West Papua. So you can find the gold easily, basically. But the price is high because of high demand. The problem with the indium and gallium is you don't treat the indium and gallium as a gold, as a wedding ring, but the price is the higher than the gold, because the demand for these two materials for technology is high, actually. So if I may inform you, the indium actually is everywhere on your face, on your eyes, basically. So you are facing the monitor, your laptop monitor, because it contains the indium. The indium is the component for the display that transmit the picture from now we are talking into your eyes. So in every smartphone, every monitor device, every computer, every televisions contains the indium. So that's why the indium demand is high, so you need to replace it somehow or to reduce it. So the technology that we propose here, the CZTS with the zinc and tin, looks promising, but it's still on the early stage. So we need to double the efficiency in order to compete SIG's technology. Perhaps this is a short answer from me, so I hope this answered the questions. Many thanks.
Thank you, Dr. Adi. So there will be like following research regarding this technology later in the future. I hope it will
Indeed,
be by
yeah.
you. Okay.
Of course, yeah. This is the core project of our activity here in AIT.
Oh wow, so cool. So Dr. Adi, I have another questions here come up from Bapak Johan Eko, STT Cahaya Surya Kediri, asking about can make a wind power plants combined with photovoltaic or solar panels for the suburb or for the small town like that?
Yes, indeed. So now we are talking about system. Yeah. So it's not about device, not only about the photovoltaics or solar cell device. So basically, if you remember the working principle of solar cells that I mentioned before, it works, of course, when the sunlight are there. So it means that from 7 o'clock in the morning until until 5 o'clock in the evening, let's say late afternoon. And what the photovoltaics or solar cell do during at night, so they are sleeping basically. They don't work. So but the wind always blow 24 hours, let's say, depending on the locations. So the wind will support the electricity at night. And of course, don't forget that we also still need the battery to store the energy, to store the electricity. So basically, wind power will support the electricity during night, and during the day. Let's say when the sun shines, everything will be powered by the solar cells. So they are complementary; they work together, and this is what actually the future looks like. So of course they can work together.
Okay, thank you so much for Dr. Adi, also for all the question. I've got one or two questions, but actually we have a time limitation. I'm so sorry, Dr. Adi. And then I'm so sorry for all the participants that has been asking, because we still have another speaker. So Dr. Adi, we are so thankful to have you. And kapan main ke Indonesia, Dr. Adi?
Insya Allah setelah COVID-19 mereda ya.
Okay, can't wait to meet you in person in Indonesia, and thank you so much for all your contribution, both
Thank
to
you
the
for having
symposium
me.
and to the world. Thank you. Have a good day, and then
You
Assalamualaikum
too, then.
warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, ladies and gentlemen, 3 speakers, it means 2 speakers to go. And then we are so thankful again. We keep saying thank you because we can see how your question keep coming up in the question list. And then how enthusiastic are you in listening and then watching the video. And then now, ladies and gentlemen, we move to the 4th speaker. And then we have been to UK, and we have been to Malaysia, going to Europe, and now we're coming back to Asia. Let me introduce you the 4th speaker, Professor Do An Tai. Hi, Prof. Tai, how are you doing today?
Yes, good morning, everyone.
Good morning, Prof. Tai. Prof. Tai, I believe Indonesia and Vietnam has the same time. Is it almost
Yes, we have the
11?
same time. Yes.
Okay. How are you today, Prof?
Oh, yes, today is busy day. Oh, sorry.
I remember you mentioned that it is like very tight schedule you have on December, but we are really grateful that you still have time for us to attend this meeting live. Thank you so much, Prof. Tai.
Yes, thank you. Yes,
Okay,
thank
and
you.
But before you start your presentation, Prof. Tai, I'm going to read your CV first.
Okay, okay.
Okay, Professor Do An Tai in University of Economic and Business Administration, Thai Nguyen in Vietnam. He actually finished his PhD in Institute of Agricultural Economics and Social Science in the Tropics and Subtropics in University of I'm so sorry if I'm misspelling this. Hohenheim in Germany. And then Hanoi Agricultural University in Vietnam for the master degree, and Thai Nguyen University of Agriculture and Forestry in Vietnam. He is now the counselor in TNU, University of Economic and Business Administration. As you can see here in front of me, I've got his CV, and it's quite a long CV, sir. So I'm going to just read a little bit. So Professor Do An Tai, Prof. Tai that I mentioned, I call him because we have some kind of research collaboration right now. Thank you so much for joining us, sir, by the way. And then he actually participate in field of research like Northern Mountains, agriculture and forestry, and then household economic, poverty and food security, livelihood and also resources management for sustainable development, environmental economics, agricultural economics, and circular economics, the one that he will present today. And then there is a lot of project and research coordinator, and then the last one is about building smart information system and also solution for create jobs for unemployment labor in Vingpuk province, and also the newest one, solution for quick and sustainable development of service sector in Baekhyang province to 2030. Wow, it's quite long. So because we have like 30 minutes, Prof. Tai, you have 20 minutes for presentation, and after that we will have Q&A session. And for all the participants,
Yes.
we keep reminding you, you can either raise your hand or you can type your question in the chat box, okay? Prof. Tai, the time is yours, sir.
Yes, thank you very much for your helping. Now let me see my screen first.
Okay.
Yes. So, can you see my screen?
Oh, we can see it now, sir.
Okay. So, from this morning, we already hear about the leadership and also some technical issue. And now I would like to bring you into economics perspective. So my topic is about circular economies and whether it can support, it can help our Earth in the future. So as you know, the current global climate change began recognized in the middle of 19th century. And for a long time we discussed, and nowadays I think all we agree about that. This subjective causes also including the human social economic activity that we produce excessive emission of greenhouse gas into our atmosphere, and also over exploitation our natural resources. And then nowadays we also have some negative impacts from all aspects of the global economy, such as it will increase the risk of spreading pests and disease to our agriculture production. And also it's the question for us about food security in the future. And climate change is also increase in frequency, intensity, and also extreme weather phenomena, such as storm, floods, drought, and so on. And also it will maybe we will lose some of our agricultural land in the near future with by climate change effects, and also in other aspects like in industry or in infrastructure, we also have some difficulty in supplying water, raw material, reduce the duration of material and component, machinery, equipment, and so on. And that means we have to increase our cost of maintenance. Additionally, we see our climate change also affects on other service like tourist, chef, or another. And climate change is maybe it's also it's caused from our activity, and it's also have negative effects on our Earth. And as we know that in our Earth, the overpopulated is now is the question. And the number in 1960 we have 3 billion, and let's say every 40 years the number will increase about 3 to 4 billion population in our Earth. And it means that we need high demand on our natural resources, and where it's come from. So that is a big question for us. And you can see here is a very nice picture, very beautiful beach, and it's maybe soon become damaged or cannot use because of our waste like this that we produce. We use the thing and then we throw it away like this. And facing with this problem, the political and the business all over the world have a in many meetings, in many conferences, and to deal with climate change. And recently, we know as COP26 was held in Scotland, UK, to make enhanced commitment towards climate change mitigation. And the concept of circular economy was firstly formally used by Pace et al. In 1990. It's referred to the new economist model based on the basic principle that everything is an input to something else. So it means that we can reuse, we can remanufacturing, these siding and so on. And which is completely different from the view of traditional linear economy, as we know. From an economic perspective, circular economies can be considered as an economic model in which all activity reach to a long life of material and reduce waste or replace the end of life concept with the restoration, which renewable energy eliminates the use of toxic chemical, eliminates the tension of waste, and so on. And the main content of circular economy are firstly is conservation and development of nature capital through rational use and generation of resources. And secondly, is optimizing the resource return by circulating the product and material as much as possible in our cycle. And the third is improving the overall system performance by minimizing our negative externality through waste control system that we're doing now. And the circular economies was expected to bring more benefits to different type of beneficiaries, which includes, for example, for the country, that we the circular economy is to demonstrate the responsibility in solving global challenges caused by environmental pollution and climate change, and also improving the capacity and competitiveness of the economy. Because our circular economy will make use of used material instead of waste disposal cost, for example. And also our circular economy will minimize exploitation of our natural resources, make the most of the value of resources, and minimize waste and emission into our environment. For the society, for example, circular economy will helping to reduce social costs in managing and protecting the environment and responding to climate change. Create new markets, new jobs for the people, and also improve the people health. That is the benefits for our society. And for our enterprise, the circular economy will contributing to reduce the risk of overproduct crisis and resource scarcity, creating the motivation into invest and innovate technology, and reducing our production cost and increasing supply chain for the markets. So that is our beneficiary. And as you know, from our left-hand side here, the model that before we take something, we make the thing, and we use this thing, and after we use this, we dispose this, and it becomes pollution for our earth, for our environment. But if we change into the right-hand side model that we make the thing and then we use it, we can reuse for another purpose, and sometimes we can remake it for different product, for example, and if we cannot use this, reuse this, we cannot remake it, then we can recycle it to make the new one, for example. That is circular economies the circular economy model can bring economic benefits to the whole world. Is about that is estimates by the scientists that it can bring about 4.5 trillion by this 2030, and therefore it can contribute 10 out of 17 goals of sustainable development from economic aspect to society and biosphere aspect as well. As you know, our Earth's capacity is limited, while the number of population is increased very fast, and it will need to the demand and also the consumption, it will be increased very fast. As you see here in the green line, why our capacity of the Earth is still stable, and it will be reduced soon in the near future. And this will make our big gap and also big conflicts in the near future. And for this, the question is, we need to change into another economic model in order to cap with this gap and in order to solve with this problem. That is from theory. And now I would like to bring you and introduce you with some case studies, some experience from Vietnam. As you know that the circular economy is early applied in agriculture. So in Vietnam, it's also is applied in agriculture. For example, the processing of manure waste in order to make the compost to fertilize for our land in order to habilitation. And now I would like to bring you to the first case study about pig farm model in Nam Định province in Vietnam. So in this model, it's related to production without waste, apply traditional techniques and scientific advance to reuse and recycle byproduct and waste in the production process into useful value for our agriculture and also contributing to the environment protection and generation. So a big farm model here, they decide on the basis of two principles. It's economy and ecology. So in this model, waste will be recycled and reused in different way. For example, the solid waste or manure can be used for composting, and the wastewater and a part of undissolved waste is sent to the biogas tank to collect gas, and then the rest here to use in another part of the farm. The wastewater after biogas process will transfer to biological pile to treat, and after that will use for irrigation. The mix of pig manure and wastewater is also used to raise earthworm. To make the most of the waste generated and raise more sub-product, like chicken when they eat the worm, cow if the farm grows grass for cow to eat, fish and crop like grass or fruits or vegetable. And the final product of the farm will include some main product like pork. It is the main product of the farm. Besides that, there are some byproducts like they produce beef, chicken, egg, fish, vegetable, and fruits, and also other byproducts such as worm, compost, grass, and worm manures. And therefore, they also need to find some other supply paths of the farm to for the markets for this byproduct. And also so this is the first case study, and the second case study is about the Helican in Vietnam. The Helican factory in Vietnam also successfully applies the circular economy model to create sustainable value for the people and also for our earth by applying so-called resource. It is generate, it is share, optimize, move, virtualize, and exchange that helps to reduce the emission and increase value from the waste. So in this model, Helican aim towards zero waste to landfill. So nearly 99% of waste or byproduct are reused or recycled in this model. Specifically, bottle and case of the beer after you when put on the market after you will resize and also reuse. A glass bottle can be reused up to 20 times, and the case of beer can be reused for 10 years. So other materials such as cardboard, aluminum, plastic, and paper are either reused or recycled. And in this model, 100% of wastewater is changed to Class A safety standards before safely return to the environment. So the benefits after wastewater treatment of Henneke is in the year of 2018, 4 out of 6 factories of Helican in Vietnam use his energy from renewable energy and biomass fuel with no carbon emission, reduced about 2.5 thousand tons of CO2 emission. And to date, 5 out of 6 factories of Heineken Vietnam now is brewed beer using 100% of renewable energy. So it is clean energy. In the year of 2019, the company purchased about 40,000 tons of dry hop and agriculture byproduct and product to serve for production and also bring the income for the people in the area. That means that the circular economy is not only beneficiary to the environment, and it's also the benefits for the community, for the local business as well. So in the future, Henneke's Vietnam has set one by the 2025 is no landfill waste, 100% of water restitution, and 100% of renewable energy. So that the companies also commit to continue share with the resource model with the business in Vietnam, and Henneke in Vietnam creates the sustainable value for the community, the environment, and the economy to achieve the long-term goal. Talking about the circular economies, we also finding and seeing some advantage and also some disadvantage. Circular economy may bring some advantage for us. For example, it's including high ability to adapt to climate change and reduce ecological risks. And besides that, it makes you circular waste to generate and even increase more byproduct for the producer, and thereby it will increasing the economic efficiency for the business. Moreover, we can see the circular economy can minimize environment impacts, especially though related to waste. But in the same time, the model also shows some disadvantages. Firstly, is the level of production may be decreased due to we have to speed the resource to recycling process, and secondly, like the case of pig farm, for example, the circular economy may also increase pressure to find out the markets for some kind of byproduct, and sometimes it's not easy to find the consumer. For example, for the byproduct like compost or worm manure, for example. Besides that, we also thinking or find out some opportunity for our circular economy. Now is the issue of sustainable development, including efforts of nature resource environment protection and response to climate change, have been recognized by the whole society already. So therefore, when we campaign on environment protection, such as combating plastic waste, have been actively responded and participated by the business and the people. So it's easy for us to convince the people to join us. A number of new models that move close to the circular economy already. So in this context, the industrial revolution 4.0 that is take place strongly. So it will provide us some new technology and very fast technology for us to apply in our circular economy. The research and promotion of technology innovation moving from real goods to the digital goods will be also great opportunity for us to develop our circular economy in the future in order to get better and more efficiency as compared to the previous model like linear economy. However, in order to implementing the circular economy, we also have to face some challenges such as the convenience of the consumer who are our customer to consume the product from the linear economy. Before they use, they have a convenience to throw it away to be the waste. Therefore, it is also we need to have to change them to change their habits, their convenience. Secondly, the local regulation on environment friendly business model and complaint of the environment law require more support from the government as well, and this is somehow is lag behind. And thirdly, the lack of infrastructure for waste treatment needs invest more money and also more energies, more time to make sure that our materials are ready to be reused. And yes, thank you. And finally, the technology is limits for our recycling technology, for example, would be enough to cover all the industry requirement, both in quantity and quality. So that is the big gap, the big question, and I would like to put here is the question for how can we join together from product, from management, from distribution, and so on and so on. And this is I would like to come up with the conclusion that to overcome with our challenging at the moment. That's the circular economy maybe is a key issue, and we need to collaborate among our stakeholders in order to overcome with this, and then we will have no more trade-off between economy and environment. Thank you very much for your attention, and it is my end of presentation, and I am happy to hear from you and also to discuss with you. Thank you very much. Yes, yes. Yes, yes. Oh yes, I think for the environmental issue is we all need to spend a lot of money, and in any ways nowadays for any kind of business or activities, I think it's not only in Vietnam but in many countries, in other countries, in your country as well. Your government also need or ask you to zone to cheat with your waste and also to zone with the issue to protect the environment. And of course, for this business, you need to invest in this. But for circular economy, I think that beside we cheat or we zone with problem of environment, we also have some kind of byproduct for us or nice or some kind of inputs for our activity. Like for example, we have new energy or safe energy to use for another part of our activity, for example. Then from that we can cover a part of our investment, for example. So I think that it's maybe it's yes, yes, another way. Yes, yes, yes. Um, I think that is possible, but that is somehow is the end of the process already. So that means it's the producer cannot not respond to they produce. I hope that we can do this from the beginning. So for every producer, they have to have plan to cheat with the waste or the environment before they sold it into the market, and let the people who use this will take the responsibility for that. Yes. 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 Thank you very much. Yes. Okay. Yes. Yes. Sure. Thank you. Bye bye. Yes. Yes. Thank you.
Okay. Can you see me now? Okay. 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 Can you see me now? Okay, camera, they cannot see me. Okay. Can you see me now? Dr. Samuel, Dr. Olusegun Samuel. Yeah. Thank you. It is 5:24. 5:24 in Nigeria. Okay, I'll send my CV to Mr. Ago. Okay, okay. Are you sure? Okay, of course. Okay, thank you. My name is Dr. Odi Samuel. Title of my presentation is Strategic Enhancer for the Pumping Biodiesel Industry in Indonesia. Before I start with my presentations, I would like to express my appreciation to scientific community, organizing community, secretary, Professor Dr. Mui Setio, member of committee, in particular Agus Setia, all other members of committee, invited guest speaker, gentlemen of the print and electronic media, ladies and gentlemen. The graphical outline of my presentation is displayed on the slides. Title, Course, Introductions, Fossil Diesels, Scenario in Indonesia's Concept of Generational Feedstocks, Overview of Generational Feedstock through RSM, Case Study, and Key Application to the strategy and relevant journals. Why is there need for biodiesel and its generational feedstocks? There's a niche because of global petroleum reserves, declinations, and escalating price of fossil diesels and intensifying challenges. This has made stakeholders to seek for clean fuel. Among the clean fuel is biodiesel. The consideration for biodiesel is masterminded because biodiesel has the properties that is German and very similar to that of diesel. In Indonesia, for my study, Indonesia are trying to keep up to meet demand in future of 10 million kiloliters Indonesia. This is important to be able to enhance and scale up production. Also, it's not toxic, it's biodegradables, environmental friendly. In the course of biodiesel, there are certain things that are needed, feedstock that are needed. The next slide will now show that the production of biodiesel entails the feedstocks as we have here, that is ecosystem service and agricultural reproductive. First generational feedstock, second generational feedstocks, which are termed as second GF, third generational feedstocks, and fourth generational feedstocks. These are the feedstocks that are classified in the course of productions of the biodiesel. Having classified, let's look at the peculiar properties of the generational feedstock. For instance, first generation feedstock entail adoption of edible oil. Example are shown on the slide: cashew nuts, coconut oil. For instance, in Indonesia, coconut is being used, and other feedstocks under first generation feedstock. In the course of second generation feedstocks, non-edible oils are mostly adopted, like jojoba, jatropha, and so on. Coconut oil. Here in Indonesia, the Indonesia government and stakeholders are making of castor. Now, not only that, the third general feedstock entail waste obtained after using fried cooking oil, animal fats, chicken, algae. The last, which is not the least, fourth general feedstocks, they are the photobiological solar biodiesels from algae. These are the feedstocks that maybe employed for biodiesel. Now, having a look at this, there's a need to classify feedstock for the purpose of this study. For instance, as I mentioned, first general feedstock, they are the inedible oil. The benefit of it is they are easy to produce, biodiesel is easy to produce from this first general feedstocks, but it affects its food supply. There is bound to be food versus fuel crisis. Second general feedstocks entail non-edible oil. It does not affect food supply, but there's a low, the process of production is very cumbersome. The third general feedstocks, they are from microalgae. It does not air the benefits of second, third general feedstock. It doesn't affect food supply, and there is high energy consumption for it, and there is low content of lipids. The fourth generation feedstock characteristics is photobiological solar fuel, and there is high investment currently on infancy levels. not much has been done. But all these classifications are very important. But from here, from the study, very generous feedstock is being mentioned because it affects, it stresses cost of production, and it tends to affect the cost and production of biodiesel from it, though it may be cheap, but it is not cost effective. In Indonesia, why there is a need for biodiesel? The need for biodiesel entails because of the depletion of world petroleum reserve. The demand for biodiesel is expected to be high, to increase exponentially in near futures. And the vegetable oil, straight vegetable oil cannot be used because the vegetable oil possess high viscosity and high density. Adoption of this vegetable oil will cause misfirings, affect the injector pumping. So to employ this waste vegetable oil, it will affect the component of this engine. In order to produce biodiesel, the major processes are being used microemulsification, pyrolysis, and transedification. Out of this process, transedification seems to be more preferable because the biodiesel produced from it has property that is similar to diesel. In Indonesia, if you look at Indonesia, the next slide, the production of crude oil in Indonesia is around 233,000 barrels per day, and there is increase in 2020. So there's a need to diversify the economy so as to be able to enhance the bioeconomies and bioenergy in Indonesia, because the demand for biodiesel tends to increase. Now, the question is, has government been making effort in Indonesia? Indonesia, so many research units have been set up. For instance, from my study, National Energy Policies put in 2006, instruction on procurement and use of biodiesel in 2006, National Biofuel Task Force was set up in 2006. Indonesia also planned towards biodiesel boom, industrial boom. But all these efforts is here to yield meaningful impact. Not only that, the government of Indonesia has encouraged adoption of 30% of biodiesel program by 2020. When you say B20, it entails adoption of 30% of biodiesel and 70% of diesel. From what we have heard, this slide, the major feedstock for biodiesel productions, mostly in Indonesia, food crops, forest residues, urban waste, algae, and among these feedstock, crude palm oil has been widely explored. The adoption of this not edible oil will safeguard the environment and provide jobs for the graduates and enhance social economic opportunity for Indonesia and as well in the whole world. In the course of productions, their energy source. The energy source has shown in figure 2 can be categorized into renewable and non-renewable energy. From the slide, the renewable and non-renewable energy, among the renewable energies are the biomass. And in this biomass, biofuel has been preferred. Why is the preference for biofuel is because of availability, accessibility, economical competitions, or the fuel is preferable. In the course of these productions, as I have mentioned here earlier, transedification is mostly preferred. When you say transedification, it entails the production of biodiesel, that is the reaction between triglyceride in the oil with alcohol in presence of catalyst to produce biodiesel and glycerol. There are factors that affect transedification, mostly molar ratio, catalyst amount, reaction time, and temperature, mostly affect the transedification process. Having said this, in the course of the production, the researchers and the industrialists, they would like to look at optimizations. The optimizations, as so in figure 4, it entails improving the systems so as to get the best to maximize the overall effect. There are mostly two methods that are being used: classical methods and multivariable statistical analysis. Each of these methods has their own advantages and lapses. For instance, the disadvantages of one variable at a time, it does not show the influence of the input variables, and for instance, there is does not recognize the interaction effect. But in the case of multivariable statistical analysis, it shows the behavior of data sets, the response, and influence the variables. So from here, multivariable statistical analysis has more predictable advantages over one variable approach. Having seen this, one of the key type of multivariable is what is called response surface methodology. What is response surface methodology is an efficient multivariable statistical tool that is adopted to optimize the classification parameters for biodiesel. The RSM, as we saw in figure 6, it entails the function are to design and analyze the experiment, modeling techniques, and to optimize. So the RSM is a set of mathematical tools that describe the relationship between the independent variables and response. From my study, from literature review that I've been studying, we have it in figure table 4. Peanuts that has been used, the reactors, the optimal condition is shown on column 3. Mustard oil has been used. These are the literature review that have been studied. Not also that figure 4 continuation, Borobudur has been used, and the optimal condition has been established. Kalangel has been used. The optimal condition has been established. For instance, the optimal condition for this is on column 4, and this study was done by Kuma 2020. Not only that, tobacco, our unit has used tobacco seeds. The optimal condition has been established. For instance, 92.2 of the yield, molar ratio of 6.09, catalyst of 1.1, and time of 78. The work is published. We use tobacco biodiesel from Nigeria, and we are able to produce biodiesel. Another waste cooking oil have been used. In our work, we make use of grey wolf optimizers and RSM, and we observe that grey wolf model, the superiority exhibited is superior to that of RSM. And Agate and Jatropha hybrid has been used. The optimal condition has been expressed in this first column. The grey wolf entail it entails is the way behavior. Okay. Oh, thank you. The grey wolf involves the mimic of grey wolf behaviors. The searching process is shown in figure 7. These are the grey wolf. The models is shown here how the grey wolf model is exhibited. In Indonesia, the graph, the production of biodiesel in Indonesia from 2004 to 2020 is shown here. It's observed from this study that 8.5 million kiloliters were produced, but Indonesia consumed 8.4. That means there will be high demand of biodiesel in the near future. There must be need. And Indonesia has taken some efforts to establish palm oil plantations, but these are lead to deforestation. And also, other problem has to do with upstream and downstream. The effort taken by Indonesian government has yet to yield meaningful results. From this study, we observe that challenges confronting the biodiesel industry as mass transfer limitations, pre-processing problems, post-processing problems, during processing problems. These are the major problems that are experienced. The detail is in figure 9. Now, after you see this problem, another problem that is experienced in biodiesel production is type of reactors and their limitations. If you look at these tables, the type of reactors and limitations are so. The batch reactor, for example, has poor adherence to automations. The capsular reactors, their problem are shown. After you look at this problem, despite the fact that there's abundant feedstock in Indonesia, there are little or no study based on approach to optimize, and the hybrid oil of castor and lauric oil has not been studied. So there's a lapse in knowledge. There's a need to adopt some method to be able to sustain biodiesel production, enhance production capacity to meet the needs for biodiesel in Indonesia in the near future. Now, from this study, figure 10, the approach is taken in 3 dimensions. We have upstream strategies, mainstream strategies, and downstream strategies. The upstream entail how to produce biodiesel from first generation feedstock. The mainstream entail safety conversions into high-graded fuel. The downstream entail easy purification and improving biodiesel properties. The next slide will now show the classification. The upstream focus on seeking more on sustainable underutilized feedstock. Here, Indonesia can look more by using more underexploited oil instead of looking at only palm oil. and coconut. Then it also involves the qualities feedstocks. Attempts have been made in this, the mainstream. Then the mainstream entail how to enhance the production, mixing of the biodiesel. The downstream involve separation of the biodiesel from glycerol. Detail can be seen in table 4, table 5. The table 5 also may mention about the feedstock. As I mentioned, upstream involves adoption of a second feedstock and third feedstock. Unicellular oil feedstock, mainstream, biodiesel refineries, chemical techniques, separation, adoption of co-solvents so as to be able to produce biodiesel in such a way that it will enhance the properties. The downstream strategy involves separation techniques, for instance, glycerol purification, alcohol recovery to prevent waste, implementation of improved separations, and economy of purification is entailed. These are also what I mentioned. Upstream involve microalgae, development of lower energies in mainstream, and downstream involve using of acidic resin. Upstream also, what we have mentioned before is also in figure table 6. Then the table 5 also talk about the example of the upstream. For instance, if you look at the upstream, we have jatropha seed, neem seed oil. It involves usage of not edible oil in this top column, and it also involves using of some suitable software to be able to market the products and to enhance system value and core properties of the biodiesel. Now, these are another method of upstream membrane separations. It's to improve the separation of glycerol from biodiesel. The importance of this is to lower energy consumption, to increase mass, to reduce mass transfer, and to reduce pressures to the conversion technology. Now, okay. Let me just conclude. From my conclusion, okay, the conclusion is this: from what we have studied, we established that the optimal container for biodiesel for hybrid oil for the castor and lauric oil is 9.9 ratio 9:1. For the molar ratio, catalyst H2SO4 of 1.0, reaction time of 30 minutes. Optimal container for biodiesel production for the hybrid, when you say HOME, that is hybrid of castor and coconut oil, is 96.4. Molar ratio 6:1, and mixing speed 7.7 per minute. The products produced from this method comply with the European and American standards. Not only that, Indonesia can make use of the strategies so as to enhance their properties and to sustain the biodiesels in the nearest futures. This is often what they can be used. Not only that, this can be used to be able to enhance, to be able to reduce controversial issue with has to do with the palm oil food gases in nearest futures and to prevent deforestation. Thank you for listening. God bless. These are the further conclusions that can be used. Thank you for listening. Okay. This is slide. Okay. Yes. Yes. Okay. Okay, read the question. Okay, very interesting. The price of biodiesel, the adoption of edible oil tend to cause price implication because of the fact that during the upstream, the edible oil will tend to conflict with the with the food supply. It tends to affect the price. But if the non-edible oil, like jatropaz, rubber seed, waste cooking oil are used, and some other waste catalysts, heterogeneous catalysts are used, the price of biodiesel production will be reduced. It will be reduced. So the price of biodiesel production has to depend on the type of feedstock that are used, type of catalysts that are used. There are some recyclable catalysts, heterogeneous catalysts that can be used to lower the production. Not only that, there are other processes like for what I have mentioned, the downstream, which entails separation, using separation techniques so as to be able to lower the waste of glycerol, like membrane and separator can be used. And by this, the cost of biodiesel production can be reduced. For example, now in Indonesia, from my study, crude palm oil has been used. This can cause food versus fresh crisis in the other futures, and the cost of biodiesel production can later be reduced if other less explored oil are used instead of depending on mainly on palm oil. For example, now the cost of production will be high because there's the competition between the consumptions and the fuel supply.
I would like to say thank you so much, Dr. Samuel, for joining us, and then very magnificent presentation. And then we are so sorry because it's quite 2 morning in Nigeria, but you're still join us live.
Yeah.
Thank you so much once more time.
Thank you. Thank you. It's 5:55 right? In Nigeria now.
Okay, thank you so much, and hope to meet you another time, Dr. Samuel, and keep up with the very good work. Thank you.
You're welcome. Thank you very much.
Have a good time, Prof. Okay.
Thank you very much.
Thank you so much. So, ladies and gentlemen, 3 hours, wow, quite a long time, but yet it is so interesting to have you all. And then we can see here in Zoom and both in YouTube, the participants is still so interesting to join until the end of the session. So we have actually have the 5 speakers talking about various information about the SGDs, the Professor Hardy talking about how is become the better and smarter leaders, and then Dr. Tony talking about the biotransform the fungi to reduce pollutant. Dr. Adi talking about advanced solar cell system. Prof. Tai, you remember talking about the circular economy, and lastly, Dr. Samuel talking about the technique for improving biodiesel production. So, ladies and gentlemen, that's the last of the seminar session. I'm Nia Kuniatin Bahtiar. I would like to say so sorry if I have mistake, and thank you so much for joining us till the morning. And then I'm going to return the mic back to the beautiful Miss Pristi.
Thank you so much for all the speaker for the presentation. A lot of insight that we got from today's seminar. And thank you so much, Ms. Nia, for making today's seminar become more powerful with your guidance. Okay, ladies and gentlemen, and the honorable participant, we will close today's morning agenda and will continuing into afternoon event at 1 p.m. until 3 p.m. by question and answer session. But before we close today's morning agenda, we'll share several information for all of you here. The first one is the discussion will be held through online Q&A forum, ConfBright, and the presenter must log into the system. And the second one is Q&A forum will be held for 2 hours and list of videos sorted by the topics. And the fourth, in the Q&A forum, all presenters are given 1 hour to ask a question or provide feedback to 3 until 5 another presenter. So you can free choosely video based on preference or study area. And the fifth, presenters who are given feedback and question could provide answer for the next 1 hour. And last but not least, giving feedback and question must be documented, so you can send screenshot, photo, or other forms and send through the form that will be posted in the chat box by the committee. For further information, kindly find the program guidelines in website, and we'll share all about the information in WhatsApp group and Telegram group. And if there are many questions that you want to ask, please don't hesitate to contact the organizing committee. Let me inform you that in this symposium, we received for about 442 abstracts. So please make sure that you can prepare your full paper version. That's all for the information, and don't forget to join us again in YouTube or Zoom by 3 p.m. because after the question and answer session, we will provide technical clinic regarding on the full paper submission. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Present in the beautiful and culturally diverse land of Magelang, Universitas Muhammadiyah Magelang has become a milestone in facing an increasingly competitive and inclusive era, forming superior generations in science and Islamic in behavior.
Welcome to Unima. With philosophical values, spirit, and new way of thinking, Unima step in by continuing to develop science and technology, build network, foster a sense of love, and improve the service quality of the 4 pillars of higher education.
In preserving environment and commitment with society, Unima always participate to create synergy and collaboration with community. With a prophetic spirit, ethos, and motivation, Unima is ready to shape qualified religious students capable in forming superior in science, Islamic in behavior graduates. To optimize the education and learning process, Unima is supported by various representative supporting facilities. Unima has 7 faculties with 21 study programs. Faculty of Economics and Business, Faculty of Law, Faculty of Teacher Training and Education, Faculty of Islamic Religion, Faculty of Engineering, Faculty of Health, Faculty of Psychology and Humanities. UNIMA implements its support for non-academic activities by fully supporting student character building activities through various student organizations. To become an inspiring generation, everyone is equally in achieving their dreams at UNIMA. UNIMA, moving and inspiring.